discussing exponential functions, which is the start of section 3 of chapter 5. Below is the formal definition of what an exponential function is, and this does create a few interesting relationships. Probably one of the most intriguing being what is f of x plus 1. So f of x plus 1 equals a, which is our base, times f of x. So that would be a times c a to the x, or if we wanted to think about it in a slightly different manner, or at this point we could have write it as a or c a to the x plus 1. Now, this is one of the theorems that dictate exponential functions, and it's one of the things that we will discuss in more detail further. In this situation, a is the base, and another way we can word it is the growth or decay factor. C represents our initial value. Okay, so let's look at some of the properties or laws of exponents. And these are all things that I know you have looked at before. If we multiply the same base, we add the exponents. If we take an exponent to a power, we multiply the exponents. We can distribute an exponent through. A negative exponent yields a reciprocal, and the 0 power equals 1. The one property that I'm pretty sure that you have worked with a lot that isn't listed here is this property, which we know to be a to the s minus t. And the reason it's not written here is because we can write it as a to the s plus negative t, which is the same thing as a to the s times a to the negative t. So in essence, it is the exact same thing as our multiplication property. Okay. So there are a couple of things that we need to be able to do. And the first one is to determine if a function is exponential or linear, or neither. And the way that we do this is we can look at the average rate of change and the ratio of consecutive outputs. Now, in this case, let's look at what we have. Our average rate of change is essentially the slope, but it's the slope between our two endpoints. So 1.5 minus negative 4.5 divided by 3 minus negative 1. And this is going to be 1.5 plus 4.5, so this would just be 6 over 4, and 6 over 4 is just 3 halves. Now, the ratio of consecutive terms, or ratio of consecutive outputs, that would be negative 3 divided by negative 4.5, or negative 1.5 divided by negative 3, or 0 divided by negative 1.5, or 1.5 divided by 0, which is a little obscene. But what we notice here, all of these give us a different value. So there is not a constant, no constant ratio. But over here, if we look, negative 4.5 plus 3 halves is negative 3. Negative 3 plus 3 halves is negative 1.5. Negative 1.5 plus 3 halves is 0. This is a constant difference. Or another way of saying that is, this is an arithmetic sequence, which means that it is linear. Okay, we're going to look at one more. Here, the average rate of change is not constant. In fact, we can see that we go from 4.5 to 6.75. That's different than if we go from 3 to 4.5. So there is no constant rate of change. So we already know that this thing isn't. This is not an arithmetic sequence. But let's go ahead and write down the calculation for the average rate of change. So 10.125 minus 2 over 3 minus negative 1. And we can simplify that down momentarily. Our ratio of consecutive outputs, however, we have 3 halves. We have 4.5 divided by 3. We have 6.75 divided by 4.5. And we have 10.125 divided by 6.75. Well, what is 4.5 divided by 3? Well, 4.5 is 9 halves. So we have 9 halves divided by 3, which is 3 halves. Here, 6.75, that would be 27 over 4 divided by 3 over 2. Well, what happens? We would multiply by 3 halves, so that would be 27 over 4 times 2 thirds, 9. That's not a 3. That is a 9. which is going to take us to a 3. And then this is going to take us to a 2, so we have 3 halves. So this is 3 halves. This value right here is also 3 halves. What that tells us, since each of these ratios is the same, this is a geometric sequence. And because it's a geometric sequence, another way of saying that is that it's exponential. Okay, that will do it for this video, and I will see you in the next